topic for this video is chemical reactions. The essential questions are how do you write a chemical reaction equation and what symbols are used in chemical reaction equations. So first we're going to review our formulas and how to write them. For ionic compounds, that would be a metal with a nonmetal or with a polyatomic ion. For example, we have calcium chloride. Calcium is a +2, chloride is a -1, so we're going to cross over the charges just like that, and that's going to give us CaCl2. Sodium chromate, we'll write down our ions. So sodium is a +1, chromate is CrO4 and it's a -2. Again, we will cross over, and that's going to give us Na2CrO4. Copper 2 nitrate, we write down our ions. Copper is a +2, nitrate is a -1. They do not cancel out, so we're going to cross over. And this time, because nitrate is a polyatomic and we're adding a number to it, it needs to go in parentheses, so CuNO3 2. So for covalent compounds, remember that is two nonmetals with no ions, and you go by the prefix. So for instance, carbon disulfide, carbon has nothing, so that's 1. Di in front of sulfide means 2, so CS2. Tetraphosphorus digoxide would be P4O10. Acids are hydrogen ions with an anion. So here's a chart to help you recall how to do this. If it just ends in "ide" on the anion, it's going to be hydro blank ic. In the blank you put the stem. So for instance, hydrochloric acid. So the formula there is just off the periodic table. With the hydrogen, it's H plus and Cl minus, and then you balance out the charges, and those two are already balanced, so we don't need to cross over, so we just get HCl. If it ends in 8, like one of our polyatomics, you're going to change that 8 to ic. For instance, sulfuric, sulfate becomes sulfuric acid, and then again you're going to balance out the charges. So we have H, which is a +1, and SO4 which is a -2. So we're going to cross over, and I get H2SO4. If it ends in "ite," like sulfite, it's going to end in OUS. So here nitrite becomes nitrous. Again, you're going to write your ions and balance out your charges. It's a +1 and a -1, so we don't need to cross over. We can just rewrite it, HNO2. Okay, so now we're going to talk about reaction symbols. So when you write a reaction, you start with the reactants, which is what you're putting in. It's like the ingredients. And then you draw an arrow, which is like the reaction is happening here. And then you write the products, which is like what you're making. So you have reactants going in, and the product is what comes out. And it always is written that way from left to right. Some of the symbols you might see are an SL and G, and that stands for solid, liquid, and gas. We like to know what form we're using our reactants or our products. We also might see a Q in place of SLG, and that stands for aqueous solution. And what that means is that it's been dissolved in water. So like if you had salt water, you could write NaCl for salt and then AQ for aqueous. An up arrow means that a gas is being given off. And that's only going to happen on the product side. If you're starting with a gas, that's in the reactant side. If you have a down arrow, that means a precipitate forms. So again, this is only going to happen on the product side. If you're starting with a solid, you'll just write an S as a reactant. And if you recall, precipitate is when it's raining solid. So like if you mix two liquids and you suddenly get a solid coming out of that, like shown in the picture there. If you have a triangle over the arrow, that's the yield sign, that means heat is supplied to make the reaction go. If you have a reversible arrow where the yield sign is, that means it's a reversible reaction, which means it can go back or forth. If you have the yield sign with a chemical symbol on top, for example, like PT, like platinum, that is the catalyst that makes the reaction go. So it's a chemical that helps speed up the reaction without being really used as part of the reaction. So to write equations, we just need to practice this a whole bunch. We're going to use the symbols we just talked about. So we're going to take this from being written in words to being written with symbols. So magnesium metal reacts with a hydrochloric acid solution to produce aqueous magnesium chloride and hydrogen gas. Okay, so we're going to start with magnesium metal. So magnesium, and it's a metal, so that tells me it's a solid. And it reacts with, so I'm adding it, hydrochloric acid solution. Okay, hydrochloric acid, I just need to figure out that that's HCl, okay, using my rules I learned for writing formulas. And then solution, if I see that, I'm going to write AQ for aqueous. And then it says to produce, so I'm going to write my yield sign, which is my arrow. And then it says aqueous magnesium chloride, so I need to take magnesium chloride and write a good formula. So I'm going to have Mg plus 2 and Cl minus 1, so I'm going to need to cross over. And so that gives me MgCl2, and it tells me it's aqueous, so I'm going to write AQ after that. And it says hydrogen gas. So hydrogen is part of Hofbrinkel, so it's going to be H2. And then the gas tells me I could either write a G or I can write an up arrow since it's on the product side. Okay, let's look at another one. When solid potassium chloride is heated, it decomposes into solid potassium chloride and oxygen gas. So I have K plus 1 and ClO3, which is a minus 1, so I need to make a good formula. Those cancel out, so I can just rewrite that, KClO3, and it says solid. So I'm just going to write an S right after that, and it just says it's heated. It's not reacting with anything. So I'm going to write my yield sign, but then I'm going to put a triangle on top of that to show heat. Okay, then it's going to decompose into solid potassium chloride. So I have K plus and Cl minus. Those two cancel out, so to write a good formula, I just have KCl, and it tells me it's solid, so I write an S after it. And then and oxygen gas. So I'm going to write plus O2 because it's part of Hofbrinkel. And then again, I could either write an up arrow or I could just write a G afterwards. Okay, another one to practice. Hydrogen and nitrogen gases react to form ammonia gas in the presence of an iron 3 oxide catalyst. Okay, so I'm going to start with hydrogen gas. So again, hydrogen is part of Hofbrinkel, so it's H2, and then I put a G afterwards. And it's going to react with nitrogen gas, which is also part of Hofbrinkel. Okay, so then I have N2 and a G after that, and they're going to react to form, so that means that I'm going to go ahead and draw my yield sign. And it tells me the presence of an iron 3 oxide catalyst. So I have iron plus 3 and oxide minus 2. So we're going to cross that over, and I get Fe2O3, and it goes over the arrow because it's a catalyst. Okay, and then I write my ammonia gas, which is NH3, and then a G. Okay, or that could be an up arrow. A piece of aluminum metal placed in an aqueous solution of copper 2 sulfate produces copper metal and an aqueous solution of aluminum sulfate. Alright, so a piece of aluminum metal. Aluminum is Al. Metal tells me it's a solid. It's placed in a solution, so I'm going to add it to copper 2 sulfate. So I have copper plus 2 and sulfate, which is minus 2. So those just cancel. I don't have to cross over. So I'm going to add that copper sulfate, CuSO4, and it tells me it's an aqueous solution, so I'm going to put AQ afterward. And then it says produces, which means I'm going to draw my arrow. And then it says copper metal. So I'm going to write Cu, and that's a metal, so it's solid, and an aqueous solution of aluminum sulfate. So I have aluminum, which is 3+, and sulfate, which is SO4, which is 2-, so I do need to cross over because those charges do not just cancel out on their own. And so I'm going to add that Al2, SO4, 3, and it tells you it's an aqueous solution.